last time we did the practical of private VLAN. Okay. In layer 2 security, one more topic or two more topics are there, that is RAGUARD and IP device tracking, that is IPDT. Now what is IPDT? IP means Internet Protocol Device Tracking. The main IPDT task is to keep track of connected host. So all know that switches are the centralized device in the star topology for connecting devices in the LAN infrastructure. Earlier we used to have, now also we have that access layer, distribution layer and core layer, three-tier hierarchy in the switch network. Access layer is device which is like, actually access layer switches are there which makes the end device or edge device connect. So the main IPDT task is to keep track of connected host. See, normally every switch maintains MAC table, or you can say CAM table, where he writes down that how many devices are connected and what are the devices connected and which port they are connected. That means he maintains, if I go here and if I show you, this is my Cisco collaboration switch. So when I say show MAC address table dynamic, dynamic means all the dynamic entries that my Cisco switch has learned, he will show me. He's showing me that on port number 1, one device is connected whose MAC address is this. On device on port number 21, he is connected to some device, his MAC address is this. In fact, he shows you the VLAN ID. That means on this switch we have 3 VLAN and 1 default VLAN. Okay. So VLAN 1 by default is there. VLAN 10 is there, VLAN 11 is there, VLAN 12 is there. If I say you, this is like 10 is called server VLAN, 11 is voice VLAN and 12 is the data VLAN. I have just named it. So when I give the command show MAC address table dynamic, I can see he has found out or he has learned some of the MAC addresses and he mentioned the port number also. So initially my switch, actually being a layer 2 device, as a data link layer device, always maintain the CAM table or MAC table, hardware addresses. Now when I talk about IP device tracking, the main task or the main goal of this IP device tracking is to track the connected host association of MAC and IP. That means here he is trying to track the device, he is trying to find out the MAC address and the IP address also of that device. That means he is trying to, we're trying to use this feature and try to track the device, or you can say the connected host. And how is doing this? So in order to do this, it sends a unicast address resolution protocol probes with a interval of 30 seconds. Like every 30 seconds is trying to send an ARP, unicast ARP. Unicast ARP means 1-to-1. See, you have heard about having an ARP broadcast where a host is trying to find out the MAC address of the gateway or a particular IP address. That IP address must be some router's IP address or some gateway, you can say, like firewall, or that IP address might be of some host. So he sends what? ARP broadcast. Why it is called ARP broadcast? Because here he don't know who is that IP, and he don't know who is the what is the MAC address of that particular device. So he sends an ARP broadcast. Here it's trying to send a unicast ARP probes with a default interval of every 30 seconds. These probes are sent to the MAC address of the host connected on the other side of the link and use layer 2 as the default source MAC address of the physical interface out of which the ARP goes and sender IP address. That means it's trying to use the source MAC address of that particular interface, generate a ARP packet and try to send it. Layer 2 frames carries the source MAC address of the physical interface out with the interface from where the ARP goes. But see, he don't know the sender, so he's sending an IP address of 000. Now the main purpose or the goal of IPDT is for the switch to obtain and maintain a list of devices that are connected to the switch via an IP address. The probe does not populate the tracking entry, it is simply used in order to maintain the entry in the table. That means now my switch is doing an extra work, extra effort. Like last time we did DSCP spoof attack. We understood DSCP snooping where he is doing some extra things. He's trying to maintain a IP DSCP snooping binding table. He is trying to maintain what? IP DSCP snooping binding table. DSCP binding table is designed or it is maintained by whom? By the DSCP server. So this guy is trying to do an extra efforts of finding out the IP address, MAC address, VLAN ID, and lot of other information of a device. So initially, if you see, the purpose of this is to get the information. So when I go here and say show IP device tracking and then put question mark and say all. Okay. Initially, it is not disabled. It is not enabled, sorry. So when I say show IP device tracking all, it will always show me this. By default, you can see when you say show MAC address table dynamic, you can see the VLAN ID, you can see the MAC address, you can see the interface. But here you can see lot of other information also. IP address, or you can see IP address and state and as an extra information. So by default, IP device tracking is disabled because this is like if you want, then only you enable. So we want now. So when we want it, we have to say what? IP device tracking all. Sorry, IP device tracking. So when I say show IP device tracking all, you can see started. IP device tracking is enabled now. IP device probe count is 3 and I told you 30-second is the interval, that is the every 30-second is going to send some ARP, unicast ARP on every interface. So you see he got some information about these devices. Like for example, if you see G1 by 0 by 3. So if I say interface trunk, you can see G1 by 0 by 3 is having a trunk port. When I say show CDP neighbor, you can see on port number 3 actually I am having a connectivity where I am having a server, a call manager server. One minute. See, I am having a switch and this switch is connected to, so this is your third interface. So if you see the third interface, on this third interface, that is G1 by 0 by 3, is connected to a ESXi server, and on this ESXi server I have publisher and subscriber installed, the call manager installed. So he's telling me, boss, you have publisher and subscriber configured on this, and you will not believe, this publisher and subscriber is carrying an IP of 100 and 101. So he's telling I am receiving two IP address on this port or this interface, okay, on VLAN 10, okay, and the different interfaces which are having this IP addresses 100, 101, 50 is switch. No, sorry, 50 is some, I think 50 is also one of the server. So he's showing me that, okay. CMD IP config / all. So in short, see here, the MAC address is BC F5D5. Can you see the MAC address? This MAC address is carrying an IP address of 10.50. That means there is a LAN card on this server which carries this. That means on port number 3 is able to learn 3 MAC addresses. On port number 10, he is having, sorry, port number 1 is connected to again a router, and this router is HQ router, and this router is carrying an IP address of 254. Show IP INT brief. Can you see? So it's telling me that, boss, on port number 1 you have 10.254. Okay. Now when I say show VLAN, there are multiple phones also connected. So suppose if I make this router as a server, sorry, as a DHCP server, like for example, if I go here and say config t IP DHCP excluded address 192.168.11.1 to 192.168.11.9, and then I if you say IP DHCP voice pool for voice, and then I say network 192.168.11.0/24, default router 192.168.11.254. So IP DHCP binding started giving IP address to IP phones. So when he started giving IP address to IP 11.13, once again you see device tracking 11.13, 11. On port number 14, 15 there is a phone. So power inline, if you see, you will find there are phones on 10, 12, 14, 15, 16. There are phones, IP phones. So when I say device tracking all, you see it started giving IP addresses to phone. I created DHCP, and switch came to know that on port number 14, then on port number 15, and port number 16 is having an IP address 11.13, 11.14, 11.15. In fact, 11.254 for 11. Okay. So I hope you guys understood that this is called IP device tracking. The command is IP device tracking, then the command is show IP device tracking all. You also have you also activate it on interfaces. So I think interface is already activated. That's why you started getting the maximum 10. You don't want the table to get full, so you said maximum 10. So IP device tracking maximum from 1 to 24. So this is the command. Okay. How to verify IPDT operation? Use this command in order to verify IPDT status on your devices. Show IP device tracking. You can also give interface, particular interface. Okay. So this is called IPDT. IPDT means what? IP device tracking. Next is RAGUARD. Now, in order to understand RAGUARD, that is router advertisement guard. See, RA is a term that comes in IPv6. All of you must be aware of IPv6, that in IPv6 you have a slack, SLAAC. Like it's like, you get a stateless auto configuration. You have two types of configuration that take place in IPv6. One is stateful and one is stateless. When I talk about stateful auto configuration, it's a simple term which everybody knows. What is that? You create a DHCP server, IPv6 DHCP server. Then you ask this DHCP server, that is IPv6 DHCP server, to allocate IP addresses to all the hosts who are looking for IPv6 IP addresses. Simple. DHCP client, DHCP server. That is called stateful auto configuration. Then in IPv6 you have one more type of configuration which is not there in IPv4, that is called stateless auto configuration. So when I don't know where I kept that slide, I have that slide of IPv6. In that IPv6 they have shown how this auto configuration take place. You call it EUI64 format also. You can see this is called stateless auto configuration, where a router is trying to send the network type information with the help of router advertisement, RA. So you have two types of messages that are being exchanged. One is RA messages and one is RC messages. RC means router solicitation and RA means router advertisement. Initially what happens when you say a machine DHCP client, when you make a machine as a DHCP client with the help of obtain an IP automatically checkbox, the machine start sending discover messages to find out the IP address. But now what happened? There is no DHCP server. If there is a DHCP server in IPv4, there will be a discover messages in the form of broadcasts, and then there will be unicast coming in from the server, and then there is a request, and then there is an acknowledgement. This is the process that takes place in IPv4 DORA, that is discover, offer, request and acknowledge in stateful auto configuration. But in case of IPv6, please note that IPv6 don't have broadcast. They have unicast, multicast and anycast. They don't have broadcast. The topic is like someone is asking, okay, Mogwil is asking, sorry to pronounce the wrong name. It's difficult for me. So Mog, I have started, still we are on layer 2 security. There were two short topics remaining. One was IPDT, that is IP device tracking, and the second was RAGUARD. So once we finish that, we'll finish the layer 2 security portion, short section, okay, where we discuss about all these spoof attacks, port security, VACL, private VLAN, STP attacks, all those stuff. So I hope you understood. So we were just talking about IPDT. We finished IPDT. It's again a very small topic, that how to track the device, how to ask your switch to track those devices. And the second one we took was RAGUARD. So what, first we have to understand what is RA. RA means router advertisement. So you see, the PC is sending a router solicitation to request. Okay, welcome. So PC is like again a client only, no? So in IPv6, what happens when you say obtain an IP automatically, they don't send broadcast. In fact, they send a multicast request on the LAN segment, and the multicast address. Can anyone tell me on which multicast address they send the request, the host? There is no broadcast. Everybody knows that there is no broadcast in IPv6. So on which multicast address all those PCs send their request? Whether it is stateless, whether it is stateful. What is the request? They are looking for an IPv6 address. So what is the multicast address? Anyone? Okay, let me tell you. It is FF02 :1 and FF02 :2. Now these two important multicast address you should know. FF02 is the multicast address used by all IPv6, you can see. So anytime if all those users want to send some information, or they want to ask something to all the routers on the link local on the LAN, then they'll always use this multicast address to find out the routers. And when the router want to reply something to these guys means all nodes, he will always, in fact, if you don't remember, if you remember, I think you must be remembering that in IPv4 also you have this multicast address 224.0.0.1 for all the nodes, and 224.0.0.2 is all routers. 224.0.0.1 and 224.0.0.2 all hosts, all routers. So again, come back once again, we are not discussing IPv6, but I just want to brief you what is RA, because if you don't know RA, how you are going to understand what is RAGUARD? So first I have to tell you, because see, many times the books used to discuss about DHCP snooping, but first I have to explain them what is DHCP spoofing, IP spoofing, ARP spoofing, then comes the mitigation, no? So I've already designed the lab guide. There are few things that I have to add it in this topic. Once I do it, I'll give it to you. port security, private VLAN, VACL. Few more example I will add it on VACL. DHCP spoofing attack, how to mitigate. IP spoof attack, how to mitigate. ARP spoofing and all those stuff. So just give me 1 or 2 days. I'll just finish doing all the layer security part and more also, and give you this guide. Okay, if I get the good diagrams, so whatever diagram also I have used it, I'll insert it so that you'll get a clear picture. So once again we'll come back to RAGUARD. You see the PC is sending a multicast request on FF02:2 and asking all the routers, okay, boss, you know who's going to give me address, or you know the DHCP server. So router is sending. So what is this message called? Router solicitation, that is RS. And in return, router is sending what? RA. What is RA? Router advertisement. The router is telling them, which is not there in this slide, but I'll tell you what router is telling. Router is telling, boss, let me tell you one very bad, okay, or you can say, let me tell you one information, or let me give you one information. So people are asking, what happened? There is no DHCP version 6 here. So all of them, oh my god, now how we are going to get the IP addresses? So he's telling, in IPv6 we have a stateless auto configuration feature. I can do one thing, I can give you the network information. Like for example, this router carries an IP of 1, okay. So what is this portion? 1, 2, 3, 4, 5, 6. 48 bits is nothing but global prefix. This is a global public IP address. And 16 bits is the subnet ID. And the rest 64 bits is the host IP. So there might be all leading zeros, so I just removed it. So this is host ID. Host ID means actually the IP address. So 48 bit is the global prefix, 16 bit is the subnet. That means this whole 64 bit, that is 48 plus 16 is 64, is actually, you can say in IPv4 it's a subnet portion, and the host portion is the next 64 bit. So see, he is telling these guys, PCs, that boss, let me tell you one thing, my master has given me this subnet portion. I am giving you guys also this subnet portion. So they are happy that at least they got this subnet portion. That means in IPv4, suppose somebody is telling you, boss, I am 192.168.10 dot subnet and my IP is 10.1, like router is telling. But this PC will say, okay, then our IP will be what? 192.168.10 dot starting from 2 till 254, right? Because one is allocated. At least they know that they belong to 192.168.10 subnet. So same way we are doing IPv6. So at least they got to know that their router on the LAN segment is carrying a subnet portion, or you can say a global prefix and subnet ID of 201, 200.1.0.0, all leading zeros are eliminated, and one is the IP. Sorry, one is again the subnet ID, and his IP address is 1. Forget his IP address. So at least PCs came to know that they belong to this subnet. Now they have to find out the host portion, that is 64 bit. So they got this instruction or hint from the router that boss, you already have a MAC address of your own which is 48 bit. You do one thing, add 16 bit more in that and you make your host IP. You got the subnet from me and you take the IP address from your own MAC address. This is not possible in IPv4. This is possible in IPv6 only. We call it as EU64 format. See, he's telling them you take your own MAC address which is hexa, add 16 bit of FFFE, so you will get a 64 bit IP address of your own, and that is unique also because all the hardware address of all the machines are different. Good, no? So this process is called router advertisement. Somebody is asking and somebody is replying. Somebody means all the clients are asking on FF02 double colon 2 and the routers are responding on FF02 double colon 1. And router is helping them actually for stateless auto configuration because he is being configured for EUI64 format. Now come back to attack. Just in order to explain you this attack, I went all the way to IPv6 and explained you. Okay. So in an IPv6 deployment, routers periodically multicast router advertisement messages to announce their availability and convey information to neighboring nodes that enable them to be automatically configured on that is called EUI64 format, or many times the term is SLAAC, SLAAC, that is stateless auto configuration. RA message, RA means what? Router advertisement. RS means router solicitation message. RA messages are used by neighbor discovery protocol to detect neighbors, advertise IPv6 prefix, assist in address provisioning. See, assisting. Router is assisting. And also sharing link parameters such as maximum transmission unit, hop limited, So there are a lot of stuff that is being exchanged between the client and the router. Router is helping the upcoming nodes to understand, to get, or you can say provisioning. So host listen for RA messages, host listen for RA messages for IPv6 address auto configuration and discover of link local address of the neighbor routers, and can also send a router solicitation mission to request immediate advertisement. That means, in short, clients are trying to communicate with routers and routers are trying to communicate with clients, or you can say host. Their communication is RS and RA. Now what is this guard and why you need a guard when everything is working smoothly? Somebody is asking, somebody is responding. So now here comes the next slide which says RA messages are not secured, they are all unsecured, which makes them vulnerable for an attacks in the network that involves spoofing or forging link layer addresses. Also, unintended misconfiguration by users or administrator might lead to presence of unwanted or see, basically they want to safeguard the RA messages between the client and the router and the client, or router and the host. They don't want anyone else who is a rogue or fake illegitimate router start giving them RA messages, and they blindly listen to those RA messages and accept the network which is not part. It is called man in the middle attack. Like I explained you in ARP spoofing. Somebody is trying to ARP to get the MAC address, and someone else is offering his own fake MAC addresses to both the gateway also and to the client also. That means this is called man in the middle attack. So here we need a guard. Again, always remember, guard do what? It prevents the attack. So RA guard works by validating RA messages on the basis of whether they meet certain criteria. That means there will be some kind of authentication, there will be some kind of communication, and then only there will be RA messages will be accepted. So RA guard works by validating RA messages on the basis of whether they meet certain criteria configured on the switch using policies. Because see, router and client communication will always be done through a switch only, no? So RA guard inspect RA messages and compares the information contained in the message attributes to the configured policy. Depending on the policy, RA guard either drops or forward the RA messages. That means whenever the messages comes out from the router and transmitted to the or given it to the switch, and then finally from the switch it goes to the client, there will be some kind of checking that will be done to find out whether the messages which are coming, RA messages which are coming from the authorized devices, that is router, and going into the authorized clients, which are the host. So just to make the communication between the client and the server safe, IPv6 RA feature provides support for allowing the network administrator to block or reject unwanted or rogue RA guard messages that arrived at the network device platform. Possible that infected router or fake router might go on giving the RA messages to the devices. Okay. The IPv6 RA guard feature analyzes this RA and filter out RA that are sent by unauthorized devices. See, RA guard feature analyzes this RA. Now, whatever RA is coming, he will analyze and filter out RA that are sent by unauthorized devices. In host mode, all RA and router redirect messages are disallowed on the port. The RA guard feature compares configuration information on layer 2 devices with the information found. So whatever, like they are trying to find out the authentic users, they are trying to find out the authentic routers, they are trying to find out. So how they are trying to find out? Simple. In a RA messages, they are trying to find out what are the information being exchanged. So the following information is contained in the RA messages. What is that? Source MAC address is there, source IPv6 address is there, source IPv6 address prefix is there, hop count limit is there, router preference. So these are some of the information that RA, that is router advertisement, is being exchanged between the router and the client. So router always give his own MAC address, his IPv6 address, so that the other users come to know. Okay. So this is like a simple configuration that you have to do it on device. Device might be a router or a L3 switch that you have to declare it. Simple two command is enough. IPv6 ND. I told you ND, network discovery protocol, is used. RA guard policy and then policy number. Defines the RA guard policy name and enter RA guard policy configuration mode. So once you do this, you enter into the RA guard. You have to specify the role of the device attached to this port. You have to say that this is a router, this is a switch, whatever. Optional commands are also that you can define the hop limit, verification and all. Okay. So this is just like you are using a feature on the switch, that is layer 3 switch or a router, when you implement IPv6. Okay. When you implement IPv6, if you are not using stateful auto configuration, if you are using stateless auto configuration, then this will be useful for you. You can go for a RA guard feature. Okay. So this was just a small this thing guard that you have to implement. Now let's move on for the firewalls. Okay. So today I'll be taking a theory of firewalls, like how firewalls came in the market, what was the, like what are the different generations of firewall. So initially there were no firewalls. When I started my career long back, I never saw any firewall in the network. Only, in fact, antivirus was also not there. People used to have operating systems. DOS operating system was there. Okay. Windows was the first they launched. That was also not good. 3.11 some name was there. Okay. So we used to do cascading and tiling in that Windows. Then somebody told that Windows 95 has come, very beautiful, good looking, good graphics. Then somebody told Windows 98 has come. Somebody told Windows 2000 has come, like that. So generation, now we have Windows 10, right? So you see, earlier we used to have these kind of names. So people were not taking even antivirus seriously. Why? Because there were no transferring of data, copying of data, very limitation was there. Like there were no networks also. Networks were there, but that also was bus topology and ring topology and these kind of topology. Floppy disk was there, but with a very limited space. So exchange of information or data was very limited. Like, people used to send the file over network only. Copying was little bit difficult. So I remember that time Cisco was very proud feeling, like, Cisco said, I am the firewall. So people asked him, what is firewall? So he said, one who intercept the traffic which is coming from untrusted area and going into the trusted area. Okay. That means you mean to say any traffic which is trying to get out or go out, or any traffic which is trying to come in, your device filters the traffic. He says yes, he stops them, he denies them, he permits them, he follows some policy, he follows some rule, and he always follows some policy, some rule, and either permits or deny. So somebody asks, what is that rule called? Simple, access list. Oh, you mean to say your router is using access list as a filtering tool and act as a firewall? Yes, he is like a firewall only, but this firewall was called as what? Packet filtering firewall or packet filters. Initially, you see, there were three generations of firewall initially. First generation of firewall, second generation of firewall, and third generations of firewall. Some people might be part of first generations, some people might be part of second, and now newcomers in the network, like hardly 2 years, 3 years, 5 years of experience, they are all third generation public. That means they only know about the third generation firewalls. Now what is first generation firewall? It is not at all a firewall only. Then why Cisco is telling my box? Cisco is assuming, Cisco is telling boss, my device is acting like a firewall. So people asked him, how come? It's simple. I am having access list which permit or deny. If I configure an access list on a router, it will permit or deny. So you mean to say a router is the firewall? Yes, first generation firewall. Okay. How it works? Simple. All the good traffic is allowed, all the bad traffic is denied. But how? Simple. You can configure an access list. So in the slide you can see router permits any traffic for 192.165.23.124. Policy is there. Other than this, as a destination will be denied. But these firewalls were called as what? Stateless firewalls. Why they were called as stateless firewall? Because they were following simple rules. What is that rule? Access list. And access list is designed this way. See, access list 100 permit TCP any. Any means anybody from internet trying to reach 16.1.1.0. That means this network, the LAN network. Permit for all the TCP traffic. But see that don't allow other than this. So I said deny IP any. If you don't say also this statement is already there by default. That is called implicit deny statement. But just because my router want to know who try to come in other than this and how this statement denied. So he made this statement and also gave a term called log. Log means all those who try to enter and was denied because of this statement is being notified by this statement. If you don't give also this statement, it will be denying the traffic, but it will not generate a log. It will not specify a log. So in order to gather the log, he said this statement anyway, and then he went and applied on the serial interface and say all those who are incoming traffic will get filtered. Good. So anybody who try to enter from internet got filtered according to the access list. Only those access list, those. But the drawback is here now what? If my user try to go and access or try to do telnet, if it is telnet, because here I accepted all the traffic, telnet and all, then it's okay because I accepted all the TCP traffic. But if my users try to do other than anything, they'll be allowed. But remember one thing, that for example, you are supposed to do only HTTP or HTTPS, that's all. And somebody try to do FTP, the traffic will be permitted because there is no filter here. There is no filter here for outgoing traffic also. But the incoming traffic will be denied. Why? Because other than HTTP and HTTPS, nothing will be allowed for all the users who are coming from internet. That means if I go to office early morning, say by 10, my security guard will allow me to go out. Why? Because the policy is all those who are the tenants or the owners of the flat in this society is allowed to go out anywhere. He will never ask. If he asks, he will get good kicks. You know, ladies will slap. Why you are asking? You say, madam, where are you going? She will slap security. Why you are asking me? You are my husband or what? This is my flat, this is my society, and we kept you as a security, and you are asking us only where you are going, madam. We'll go anywhere. I'll go to parlor, I'll go to school, I'll go to college, I'll go to anywhere. This is my choice. Okay, so he will not ask because there is a statement here that all the society users, all the society members are allowed to go out without any problem. No policy. But what is the policy? Why you have kept security guard? Because there is a policy that all the users who are coming from outside into the society will be denied. According to this statement, we will be denied, no? All those are coming in. So what will happen? The madam who went early morning, or if I went to office early morning, in the evening I'll be denied entry. Why? Because there is a policy that all those who are coming from outside will be denied. So my security officer, from where you're coming? Outside. Where you're trying to go? Inside. Sorry sir, denied. This is called stateless behavior. Because router is following the access list. He says, sorry boss. I said, no, I went in the morning. That is not my lookout. You went in the morning outside. My lookout is what? I have been told that anybody coming from outside inside this society should be denied. So I will not allow anyone in. This is called stateless behavior. Nobody will tolerate this. People will kill him if we try to do this. So my first generation firewalls were purely stateless. Stateless, see how they are behaving. All my traffic other than HTTP and HTTPS is stopped. Why? Because I have a policy here that allow only HTTP and HTTPS and deny everything else. And I applied it on S0 by 0 for inbound traffic. So when my user goes out on internet for any other services like telnet or SSH, so in telnet or SSH, three-way handshake. So other handshake is denied. Why? Outgoing traffic is allowed because there is no policy, but incoming traffic is denied because there is a deny policy. This is called stateless behavior. So all the first generation firewalls were stateless. Secondly, they were having a big other drawback. What was that? This guy purely works on L3. Afterwards, they made extended access list which can understand protocol service also, TCP and UDP port numbers, no? So if you consider extended access list, he will understand the protocol, he will understand the source IP address, he will understand the destination IP address, he will understand the service. That means maximum layer 3. Layer 3 is definitely there, and layer 4 also now. So layer 3 and layer 4, this firewall, which Cisco is telling this is my firewall. Wow, good. So Cisco is telling this is my firewall, which is a router. So if this is a firewall, first of all, it is a stateless firewall. Secondly, he works only on layer 3 and max on layer 4. That's all. He doesn't understand application layer, presentation layer, session layer, data link layer also. He understands only network layer and transport layer. That is layer 3 and layer 4. So there you see there are a lot of drawbacks that people notice on this firewall, which was not actually designed as a firewall, it was already designed as a router to do routing and switching. But Cisco did what? He added one more feature called packet filtering, because he can transmit the packet and receive the packet. So he added packet filtering. What are the functions of a router? Doing routing, exchanging of network, inter-network communication, finding out best path, or you can say best path selection. And then one more feature is there, what? Packet filtering. And packet filtering take place with the help of access list. So Cisco was trying to tell people that, boss, my device is firewall. Then people started telling, boss, your firewall is not hopeless. Why? Because your firewall is stateless. Secondly, your firewall works only on layer 3 and layer 4. That means it only take care of the source IP and destination IP. In fact, you should know that router always sees the destination IP address in the packet. They never sees the source also. So what happens if anybody hides some virus, worm or trojan in the data part? He is not able to recognize because he looks only at the source part and destination part. That means always remember, in when some trucks enter the city, they are always being checked. We have a check post in our city also, Mumbai. Now they removed the check post. So now on that check post, what was the problem? They used to stop all the transport vehicles, heavy vehicles, and they used to check what they are carrying inside the city. So according to the list of allowed material, they used to allow all the vegetable trucks inside the city, or you can say fruits truck inside the city. So any truck or any transport that comes with a tag that this is a fruit or this is a vegetable, they'll allow him. Good na? There is a tag on the boxes vegetables, they will allow. There is a tag on the boxes fruits, they will allow. This is a policy. But now some anti-social elements, like you can say some terrorists, came to know that the security or the checkpost always look into some criteria and allow the packets. So what they'll do, they will put a tag on the boxes fruits and vegetable, and in fact they will put fruits also, but inside the fruit, right, top they will put a layer of fruits, and inside they might put some guns or some explosives. Dangerous. So what these security people will do, they will say, oh, what is the source? Truck. What is there inside the truck? Vegetable. What is the destination? City. Allow. Permit. They won't see, they won't open the boxes and see what is there inside, because they have the capability only to see the source and destination. They won't see the data. So my access list never see the data. My access list always filters the traffic on the basis of what? Extended access list. If it is there, then it will always check care the protocol. So here you see TCP. Okay, TCP. Secondly, what they will check? Source matches, destination matches, go, permit. They won't see the data, boss. So these were some major drawbacks that we noticed during the first generation firewalls, and then people rejected these firewalls and they say, no, this is not a foolproof firewall, this is a temporary firewall. If you don't have anything, like you have a stick, nice stick, and you want to fight with a soldier who is having a Sten gun, or a terrorist who is having a Sten gun. And the same thing happened few years back in Mumbai when terrorists came with their automatic rifles and automatic guns. Our police were helpless. They were just trying to stop these terrorists with the help of a stick. How can you stop a terrorist with the help of stick? They are already equipped with latest firearms. But started carrying guns? No, you're wrong. I am telling started carrying vegetables, hiding guns. Top you are having vegetables. What my access list will do? Okay, vegetables. He will never see inside this. Terrorist knows that they will always see what? The tag. What is there inside the tag? Vegetable. So what is there inside the packet? Have you seen the packet? Data, source IP and destination IP, right? So they will only match source IP and destination match. They will never see inside the data, boss. I told you, these terrorists came to know that they are accepting vegetable and fruit trucks. So they are just putting a label on the boxes, vegetables. Oh, you are carrying vegetables, good, go man, access list matches. Oh, you are carrying fruits, access list matches, go man. So terrorist knows that if you take vegetables and fruits and then you go, these trucks are allowed. If you are not checking each and every truck, it is possible today also that people might fool you. But now we have advanced firewalls. We have advanced security. You go to airport, I remember people were never checked for anything. I will tell you one true incident, that one guy brought gold biscuits, that I tell you in 1980s and 85, gold was smuggled inside the country, India. Gold smuggling used to be done. I'm not talking about drugs. That time drugs were not there. Only gold smuggling. So how people used to smuggle gold inside this country? I remember I have seen one man carrying a gold biscuit inside his shoes. Somebody is carrying gold biscuit inside some tiffin box. He might is carrying some cake or pastry. He has inserted gold biscuit inside the cake and is carrying on the airport. Nobody is bothered to check. Okay, you are carrying a pastry or a cake. Okay, go man, have fun. Nobody is looking inside that. I remember he hided something in his shoes. He hided one gold chain in a box called powder box, talcum powder box. But now can you hide a gold or something like that in your bag or in your shoes? No, they will scan you, boss. There are high end scanners which can easily rectify if you're carrying a food product inside your bag, or if you're carrying some gold, or if you're carrying some gun. You see, every packet is getting scanned. That time the scanners were not there, man. I remember people carrying something inside their stomach also. Smuggling, eating diamonds and eating gold and eating drugs and then coming with that. But now we have that facility. We can sonography. That time sonography scanners were not there, man. High-end scanners were not there. So I'm talking about first generation, means 20 years back. Okay. So they are not carrying guns. They are carrying vegetable only, but hiding guns inside that vegetable. So our firewall has to know about that. Data was never scanned in those days. Only still access list is just looking at the source and destination. But now our firewalls are stateful. I'm talking about stateless firewalls. After that, they came out with second generation firewalls, application layer gateways. But application layer gateways were definitely not good. Again, there were some drawbacks, costly. For every session, you see, client and server has to communicate directly, but they were just breaking the client server model. What is that client server model? That client should communicate directly with the server, but they were not. See, a request is being sent to the app. It's like a proxy server. Internet is connected to the proxy and you are getting the internet from the proxy. So second generation firewalls were also like a flop show, though they were working on all the layers, because you can see the term is application layer gateway. But the drawback was it is costly. Secondly, for every connection, there are 4 connections. Request is sent to the application layer gateway. The request get repackaged. Response comes in and then repackaged. That means there is no direct communication between the client and the server. Client server model is getting breaks. There is some mediator in between which is acting like a gateway. So I think I have not seen these kind of gateways implementing in the industry. And then finally stateful firewalls came into market, And the best example of stateful firewall is your earlier fixed firewall and then ASA. Now what is the term stateful? So stateful firewall means those who are stateful firewalls will always maintain a session table called state table. Why they are called stateful firewalls? Because like same example, like router is receiving a packet and he is sending it out on the internet from the LAN users. So he make an entry in the state table, and in that state table he write down the connection detail, like what is the source IP, what is the destination IP, what is the source port, what is the destination port, what is the protocol, what is the service, timestamp, time also. And then he maintain this table for all the outgoing connections on internet. And when the connection come back, if it is a TCP connection, if the connection come back, he will always check for that connection in its state table and try to tally that this is the packet which is actually going from the LAN on internet and it is coming back. So if it is coming back, I should allow him, I should not deny him, because this is the current packet, this is the current connection. So stateful firewalls who are really working in a very good, see this is like they are showing about the Cisco IS firewall. Nowadays we have Cisco router with a facility of IS firewall. That means I'm not talking about first generation firewall. Now in fact router firewalls are also third generation firewall acting stateful. That means they can also filter the traffic like ASA, but with some limitation. You cannot use one device for doing everything. Na? Now like mobile phones, smartphones, you are using it as a radio, you are using it as a music player, you are using it for multi-purpose. But it is better you use certain things only for certain things only. So there was some dedicated firewall who were considered as stateful firewalls doing stateful inspection. Actually remember this term stateful has come, this is a patent word of Checkpoint in those days. But then Cisco also started using that word stateful. This is a patent word of Checkpoint. Checkpoint firewalls were called as stateful firewalls. And you know, Checkpoint was the cutthroat competitor of Cisco. Cisco and Checkpoint were the having cutthroat competitions. Checkpoint was GUI, Cisco was command line. Then Cisco overcome his problem with GUI using Nokia black boxes and PDM, Fixed Device Manager. Checkpoint did a tie-up with, Checkpoint did a tie-up for boxes with Nokia black box. Cisco came out with PDM, Fixed Device Manager. So Cisco overcome his problem by making a GUI. Checkpoint overcome his problem by making a boxes. So now both Checkpoint is also having UTM boxes as a hardware, but his main focus is on GUI. Cisco already having an hardware, and now Cisco is also GUI. So you see in this slide, you can see that how the Cisco IS firewall acting as a stateful, writing down even the source, destination, source port, destination port, sequence number, flag, sync packet. If it is a sync ACK, you can see source changes. 30.0.50 is acting like a source. Destination is 0011. Okay. Source port was 1026. Destination is 23. 23 means telnet. So when the reverse packet comes, the source become 1026 and the destination become, the source become 23 and the destination become 1026. This is a sync ACK packet. So always remember the term stateful means writing down the connection information. If it is TCP packet, if it is UDP packet, there is very less things to write it down, but still he will maintain a connection. if it is a echo request packet, if it is a echo reply packet, he can understand all the protocols. He can understand TCP sessions, he can understand UDP sessions. Okay. So I hope you understood what is stateful and what is stateless. Now when we talk about firewall, what is the firewall? Network security engineers must protect valuable resources within a network. See, here we are talking about a device which is going to protect our network, is going to protect our data, is going to safeguard our data, is going to safeguard our business. Okay. So in Cisco also, Cisco has come out with earlier PICs and then ASA boxes, adaptive security appliance. PICs was purely a firewall, but ASA was not just a firewall. ASA was doing multi-purpose things. ASA is doing URL filtering, ASA is doing application inspection, ASA is doing AAA authentication, ASA can do failover. There are a lot of stuff that my ASA can do. That is why the name was Adaptive Security Appliance. Adaptive. Okay. They were using Avid architecture for voice and video, and then they were using SAFE for security, some architecture. So I'm talking about a device which actually divides a network into two parts, that is trusted and untrusted. Always internet is considered as what? Untrusted, and your LAN is considered as what? Trusted. Okay. So firewall is going to act as a barrier. Firewall. Why it is called firewall? Why it is called firewall? Because the firewall term has come from the history. Like, we used to have in Mumbai and in many places like China, they say we have slums. Now in the slums, what happened? They have their houses stick to each other. So if there is a fire, the news comes that 100 houses are burned or 1,000 houses burned together. How come 1,000 houses are burning together? Why? Because they are all connected with each other. So now, if you are making a society, if you are making a colony, you don't have all the buildings stick to each other. There is a wall that is protecting them, and this wall is made up of fireproof material. That is why it is called firewall. So the term firewall comes from those walls. So firewalls are something which is acting like a barrier between untrusted and trusted network. But companies always say, or you also know, that we cannot fully trust. Okay. And remember one thing, firewall must be always only in the path and not outside the path. Like for example, if I am appointing a security, I will make him stand on near the gate where the people come from outside. I will not make him sit on the terrace of my building. Why? Because if he's sitting on terrace of my building and watching, he will get a very good view also. But then if somebody try to come in, how is going to stop him? Because he's sitting on top. If he come running, also it will be delayed because the person might rob things and run away. So always remember, security has to be implemented exactly in the path. My LAN is considered as trusted, no problem. But then I also don't trust my LAN. You can say semi-trusted. So you see in this diagram they have shown that the data center trusted zone is something where you have servers, and untrusted zone is your LAN. So I also don't trust. I go in my company, I keep my bag near me only. I trust my company, but then I don't trust the people coming in there. There might be somebody coming from outside, he might take away my laptop back, gone. Company will say, you have to take care of your valuables. We are not responsible. So always I keep my things safely. Company has given me some safe lockers also, where I can keep my things. So you see, when we talk about firewalls, they also carry some zones which are demilitarized zone. Why they are considered as demilitarized zone? For two reasons. If I keep my servers here, then LAN users can communicate directly, because see, if there is a switch and if there is a client and if there is a server next to it and if they belong to the same VLAN, why they will go to firewall? They can communicate directly on the layer 2 device itself. But suppose if I don't keep the server here, if I keep the server here in demilitarized zone, then my, and in, if I am keep making another interface, then the subnet also differs. So if there are two different subnet, then they have to go to layer 3 device. My firewall is also a layer 3 device. So if now client come to firewall to reach server, they will definitely have to pass through firewall. So now firewall will come to know why the clients are visiting server, what is the requirement. You can set the policies. If they want to go on internet, they will again come to firewall that we are looking to go on internet, please allow us. If somebody is trying to visit servers. So demilitarized zone is having two advantages. First, if I separate the server from the LAN into demilitarized zone, I can trap my client users or I can trap my own LAN users to find out what they are doing with the servers, why they are visiting the servers, who is authorized for which servers. Firewall can do, or firewall can keep a tab on all those users, because now the servers are placed in somewhere else, not inside the LAN. Second advantage of having demilitarized zone is people coming from internet will always go and visit demilitarized zone. They won't come to LAN. If suppose you are keeping the server in LAN, then people will come to your LAN. So you're going to make a data center, you're going to make a zone called demilitarized zone. You can say, what happens if somebody attacks the server? The attack is only here, at least your LAN is safe. You can make multiple demilitarized zones. If you have many interfaces, you can make multiple demilitarized zones. So suppose you have internet on one interface, you have LAN on one interface, you have DMZ1 on one interface, you have DMZ2. You can keep public servers here. You can keep private servers here. This is your outside. This is your inside. So Cisco started giving name to the interfaces. We call it naming of interfaces. Inside, outside, demilitarized zone. Cisco says my interface is never identified as G0 by 0, G0 by 1 or G0 by 2. No. You have to give name to those interfaces. Inside, outside, they are all, when you see the interface, you should recognize that this interface belongs to LAN, this interface belongs to outside. You can give LAN, you can give WAN, you can give that terms also, but at least give some name. You can give your name also. So I am giving one interface Shiva, I am giving one interface Khan. He will accept it. One interface Mirza. Okay. But what is the drawback then if I give one interface Mirza, one interface Khan, one interface Shiva, one interface something else? What is the disadvantage then? Can you give the name like that? Yes, I can give, man. But what is the disadvantage? Anyone? If someone leaves the company, like Khan leaves the company, he knows what is Khan. He knows what is Shiva. So administrator leave the company. How the other administrator will come to know what is the meaning of Khan, what is the meaning of Shiva? So it is better you use the recognized name, that is inside, outside, DMZ. For whom? For naming the interfaces. So in ASA what happens? Always you should name the interface. And I hope you understood what are the advantages, two advantages of having a demilitarized zone. I don't trust my LAN interface. I don't trust my LAN user. So I want to separate the servers from LAN to some other zone. Secondly, if somebody is coming from internet to access the public server, and if something happens, at least it happens only on the demilitarized zone. My other demilitarized zone and in LAN zone is safe. But if I keep all the server in one place, LAN also on one place, servers also one place, public server also one place, then if one attack take place, all of them will get attacked. That is why you see you place the server in data centers. So demilitarized zone is like somewhat trusted, not fully trusted. Now firewall works on policies or two condition. What is that? Permissive access control and restrictive access control. Or many times we say implicit policy and explicit policy. Now implicit and explicit policy I explain you later on, but permissive access control means all traffic is allowed to pass through unless it is explicitly blocked. Like in our ASA also, all the traffic from inside zone is fully permitted to go on outside zone without any restriction. This is the default implicit rule. What is the rule? All the traffic from inside, this is my firewall. So all the traffic from inside is allowed to go outside without any restriction by default. That is called permissive access control by default. Huh? But no doubt the name is outside. No doubt the name is what? Inside. And in ASA we have security level also. So the security level of inside is 100 and the security level of outside is 0. So now the rule is what? Any traffic coming from high security zone and entering into low security zone is fully permitted without any policy. Firewall will allow him. But restrictive access, no traffic is allowed to pass through unless it is explicitly allowed. So I told you, there are two rules, implicit rule and explicit rule. Implicit rule means all the users from 100 or all the people or all the network users from 100 can easily go to, so 100 is like that and 0 is like that. If you keep your car here, it will go without fuel only, it will go down. You don't have to in fact start also the car easily. But if you have a car here, if you if you put a fuel also, it will be difficult to reach there. So all the traffic which is coming from 100 security level and goes to 0 security level will be easily permitted, but all the traffic coming from 0 security level towards 100 security level, that is low level to high, needs what? Some policy. And who's going to build that policy? You as an administrator. And that policy is called explicit policy. And what about the policy which was allowing the traffic from 100 to implicit? Implicit means default rule. Explicit means the rule which you design. Implicit means default. By default, it's allowed. Explicit means now you say no, I don't want to allow. Like for example, what is the implicit rule in my house? All my kids I don't have 10 kids, I am having 2 kids. Both my kids are allowed to go to school, no restriction, allowed to go to play, no restrictions, allowed to go anywhere from my house. But then my son is trying to leave my house at in the night, midnight. I have a policy. Don't leave the house in the midnight for doing anything. Night time you are in. If you want to do anything, you go in the morning. Why you want to go in the night? Nights are not good. Night outs are not good with friends. So the default policy is what? Everything is allowed. But what is the explicit rule that I have made in my house to my kids? Nobody should go after 10 outside the house, or nobody should go outside the house after 9. 9 p.m. is the last time. That is the restriction time. That is explicit rule. What is the implicit rule? All are allowed to go. But what is the explicit rule? Don't go in the night time. Explicit rule. Got it, all of you? Permissive access control and restrictive access control. Understood? Any question? Implicit rule and explicit rule. Demilitarized zone advantages and what is demilitarized zone? What is the difference between stateful packet filtering and stateless packet filtering? These terms are very important to understand firewall. Now, if we talk about firewall, you see ASA firewall, there are a lot of features. Actually, it is a stateful packet filtering engine, application inspection and control, user-based access control, session auditing, botnet filtering, URL filtering, UC proxy, DOS prevention, traffic correlation, VPNs, site-to-site VPN, remote VPN, high availability with clustering, redundancy of interface, ether channel, traffic policy virtualization, routing function, NAT, transparent and routed mode, DHCP, DNS, PPOE, IPv6 support, multicast support. You see there are a lot of features available in this box. You can also make him DHCP server. You can also configure NAT. You can also, he's having a support to IPv6, multicast support, DNS. You can make him TFTP server, FTP server, anything you want to make. Routing, REAP, EIGRP, OSPF. So you see, my box is not just a firewall, it is an adaptive security appliance. Adaptive. Any new thing can be done with this box. It's a flexible box. And now they have come out with firepower. So ASA is also there, firepower is also more features. We'll see next time what are the difference between ASA boxes and AS firepower. Okay, this is an old sheet showing about how these boxes having ports. We have new models coming in now. These models are now no more working. So I hope you guys understood today's lecture. Any doubt regarding firewalls? Any doubt? Anyone? So next time, few some more theory is there, and then we'll start practical with ASA boxes. Okay, so we'll do certain topics in ASA, then we have certain topics in firepower, and then we'll finish ASA. There are a lot of topics in ASA also that we have to do, NAT and basic configuration, failover, transparent firewall. Okay, so we'll see the practical of all those stuff. I hope you guys understood this lecture. Okay, I'll send you this video tomorrow. Okay, so is firepower devices next generation? Yes, of course, it's also a next generation devices. Because see, I told you, you need to understand things, like as things are changing, attacks are also changing. GUI, FMC, through FMC, okay, firepower management control. People like GUI, no, but ASA can be done in CLI also and GI also. Okay,
Okay.
thank you all of you. Meet you next lecture. Bye, take care.